to ಎಲ್ಲ ಹಲೋ 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 yes, good evening. Can you hear me? Arpita? Hello? Yes. Hi. Can you hear me? Yes. Is the board visible to you? Okay. Is the board visible to you? Okay. Continue with some basic concepts in chemistry. Basic concepts in chemistry. We'll continue. Today with we completed first topic, measurement, units and measurements we studied in detail. Let us continue the second topic now. Here we will be learning laws of chemical combination. Laws of chemical combination in the today's class, and also we will be studying different laws of chemical combination. Then we will be studying atomic weight. What are the different laws of chemical combination were proposed? Means you studied in the bridge course and in the 10th standard that a particular chemical reaction, okay, a particular chemical reaction takes place. Generally, what is the law behind them? How the chemical reaction takes place? What is the law behind them? We are going to learn in this session. That is laws of chemical combination. Okay. See, the different laws were proposed by different chemists. The first law is called as law of conservation of mass. Law of conservation of mass is the first law. Second law is called as law of definite proportion. Law of definite proportion. Law of definite proportion. And the third law is law of multiple proportion. Law of multiple proportion. We'll try to understand different laws today. Law of multiple proportion. Then Gay-Lussac's law of combining volumes. Gay-Lussac's law of combining volume. Open your notebook. We'll try to learn combining volumes. Combining volumes. And Avogadro's law. Avogadro's law. We'll try to understand Avogadro's law. Right. I will explain you with an example, then we will write the law of conservation of mass. Look at here. For example, if you take reaction between hydrogen and oxygen, they combine forming what? If you do electrolysis, hydrogen and oxygen combine forming hydrogen water by using electrolytic method, or even you can take the decomposition. Observe here. What the law of conservation of mass states is that matter can neither be created nor be destroyed. Now see here. As on date, you know that hydrogen has got how many hydrogen atoms here? 2 hydrogen atoms. How many hydrogen atoms on the right hand side? 2. Now oxygen atoms are 2. Here oxygen atom is 1. If you take the atomic masses here, what happened is atomic mass of hydrogen is 1. Therefore, you will get 2 grams of hydrogen. Oxygen is 16 2s are 32 grams. And water consists of 18 grams. Hydrogen 2, oxygen 16 plus 2, 18 grams. See, you studied how to calculate molecular weight in the school level. See, hydrogen is neither created nor destroyed. But 2 atoms of oxygen give here only 1 atom of oxygen. Therefore, you are told to balance the chemical equation, because number of atoms in the reactant side must be equal to number of atoms in the product side was for the first time given by this law of conservation of mass. Law of conservation of mass was proposed by Lavoisier. He said that the law states that, statement of the law of conservation of mass states that matter can neither be created, like a law of conservation of energy is there, energy can neither be created nor be destroyed. Similarly, matter can neither be created nor be destroyed. ಏನಿದ್ರ ಅರ್ಥ? ನಾರ್ ಬಿ ಡಿಸ್ಟ್ರಾಯ್ಡ್. ಅದ್ರ ಅರ್ಥ ಏನಪ್ಪ ಅಂದ್ರೆ, ದ ಮೀನಿಂಗ್ ಇಸ್ ದಟ್ ಈ ಜಗತ್ತೊಳಗ ಮ್ಯಾಟರ್, ಆಲ್ ಮ್ಯಾಟರ್ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಅಟಮ್ಸ್, ಯು ನೋ, ಆಸ್ ಆನ್ ಡೇಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಡಾಲ್ಟನ್ಸ್ ಥಿಯರಿ. Means atoms can neither be created nor be destroyed. When it was started, the law of conservation of mass is very close to law of conservation of energy. See, according to Einstein, you know, energy and mass are related. In the nuclear physics, you will come across this energy. Means energy, a part of the energy of the nucleus is converted into energy, right? So after this law was established, means the law of conservation of energy states that energy can neither be created nor be destroyed. It is the law you studied in physics as well as in chemistry. Once this E is equal to mc square was established, energy and mass matter can be related. In a nuclear fission reaction, a part of the mass of the nucleus is emitted in the form of the energy. Therefore, matter and energy are related. Therefore, the law of conservation of energy was restated by Lavoisier as a law of conservation of mass or matter. So, therefore, it states that matter can neither be created nor be destroyed. So, to be in accordance with this is the universal law in the universe. You can include in the universe, matter can neither be created nor be destroyed. What happens is, here you can observe, if I do not balance it, see, this equation we learned that is a skeletal equation. And in chemistry, in the basic bridge course, we told that equation should be balanced. Why equation should be balanced? Means number of atoms of reactants must be equal to number of atoms of products. Why it should be equal? So because according to the law of conservation of matter, if you do not balance it, there are 2 oxygen atoms in the reactant side, on the product side there is 1 oxygen atom. Means 1 oxygen atom is destroyed. Then you are going against the law of conservation of matter. Therefore, a chemical equation is to be balanced. Reason for balancing of chemical equation. Reason for balancing chemical equation. Why many of you ask, sir, why we should balance a chemical equation? We should balance a chemical equation according to this law, because a chemical reaction takes place according to the laws made by different chemists. They have made the law. We have to follow that law. Therefore, to be in accordance with the law of conservation of mass given by Lavoisier, we have to balance a chemical equation. Therefore, you write that there are to balance oxygen atoms are 2 here. To make oxygen atom 2, we'll write it as 2. Now hydrogen atom is disturbed. Otherwise, what happens here? 2 2s are 4 hydrogen atom. Here, how many hydrogen atom? 2 hydrogen atom. If you do not balance hydrogen, then 2 hydrogen atoms give rise to what? 4 hydrogen atoms. It is impossible according to this law. Means you are creating more hydrogen atoms here. Here, oxygen atoms are 2, oxygen atoms are 2, they are balanced. Means oxygen atoms are neither created nor destroyed. Now, if you do not balance the hydrogen, there are 4 hydrogen atoms. If you do not balance the hydrogen, then it becomes what? Imbalanced. To balance it, you must take a 2H2. Then you write it 2S2, 4 hydrogen, 4 hydrogen. Neither the matter is created nor destroyed. 2 oxygen atom, 2 oxygen atom. Neither the matter is created nor be destroyed. I hope you understood the first law. First law, that is law of conservation of mass. It was given by Lavoisier after the establishment of energy and mass relationship by Einstein. This law was proposed in chemistry, and because of this law, every chemical equation after writing, it is mandatory to balance it. If you do not balance a chemical equation, teachers will cut your marks. Why they are cutting the marks? If you do not balance it, always we say that balance it. The skeletal equation should be balanced. Why? The reason is law. Because chemical reactions cannot take place without any law. Entire universe is running according to a law. Right? Entire universe is mathematically perfect. Therefore, this is a mathematical thing. Law of conservation of matter says that matter can neither be created nor be destroyed. The meaning, simple meaning of this is number of atoms of reactants, number of atoms of different elements in the reactants, different elements, number of atoms of different elements in the reactants must be equal to, the practical application of this law must be equal to number of atoms of, note it, number of atoms of different elements in the product side. Then it is called as equation. Meaning of equation in mathematics means LHS is equal to RHS. Therefore, it is called as chemical equation. Number of atoms of different elements, in products. This must be equal. In order to equalize the number of atoms of different elements on the reactant side, the number of atoms of different elements in the product side, we call it as balancing. That is what is balancing. And this law, to be in accordance with this law of conservation of mass, any chemical equation, after writing the formula of the reactants and the products, it should be balanced. This is the practical application of this law. To be in accordance with the law of conservation of mass given by Lavoisier, we have to balance a chemical equation. I hope you understood the value and importance of this law. Okay. I hope you understood. Any doubts in this? Okay. Now continue with the second law. Second law states that the law of definite proportion. Law 2, second law. What is the law of definite proportion? Now we will see. I can prepare water by different methods. What are the different methods of getting water? Suppose that I take NaOH, sodium hydroxide plus HCl. Sodium hydroxide plus HCl gives rise to what? NaCl plus, you know that, water liquid. Okay. And I can prepare water by many methods. See, I can prepare water by burning this any hydrocarbon, say methane. When burnt in the presence of oxygen, any hydrocarbon, this is present in CNG, in cars, go gas, methane will be present. Even gobar gas consists of methane. You studied in the 10th standard. It forms only two products. One is carbon dioxide, another one is water. Right? Here water is prepared by neutralization reaction between, this reaction is called as, you studied in the 10th standard, called as acid, base and acid react forming salt and water, is called as neutralization reaction. Means by neutralization reaction you are getting water. Here this is combustion reaction. Combustion reaction. Using combustion of methane gas and oxygen gas, you are getting carbon dioxide and water. Balance them if they are required. Without balancing, equation becomes meaningless because you cannot violate the first law. Carbon 1 atom, carbon 1 atom. Hydrogen atoms are 4 here. There are 2. If you do not balance it, you are going against the Lavoisier law. That is law of conservation of mass. Therefore, I must take here 2s2o. Okay. Now, you count the number of oxygen atoms. Now, hydrogen atoms are same, means neither created nor destroyed. Carbon atoms are neither created nor destroyed. What happened to oxygen? There are 2 oxygen atoms here. How many oxygen atoms on the product? 4. Means 4 extra oxygen atoms is created. Means if it is created, that is against the law of conservation of matter or mass. Therefore, oxygen is to be balanced. To balance it, we write by hit and trial method 2O2. 2 2s are 4. Now 2 plus 2 is 4. Now the equation is balanced. Now the Lavoisier law of conservation of mass is obeyed. Now my question is, irrespective of the method of preparation, we have prepared water by combustion here, we prepared water by combustion of that neutralization reaction. But what the law of definite proportion says is that the hydrogen and oxygen, see, what is the atomic weight of hydrogen? There are 2 atoms of hydrogen. 2 atoms of hydrogen. What is the atomic mass of hydrogen is 1. Therefore, 2 into 1 is 2. What is the atomic weight of oxygen? Atomic weight of oxygen is 8. The ratio is if you divide it 2 ones are 2 eights are. Always you take water, always hydrogen and oxygen will combine 1:8 by mass. By mass. You prepare water from any method of preparation. Therefore, this law of definite proportion states that any compound, any pure substance, right, contain, right, atoms of different elements combined in a definite proportion by mass, irrespective of the method of preparation. In a compound, atoms of different elements combine in a definite proportion by mass, irrespective of the method of preparation. These examples you can note down. First you note down the example, then you understand the law, then you can write the statement of the law. Without understanding, don't write it. Now, we prepared water by 2 methods. This is a first method, this is second method. By neutralization reaction of acid and base also you can get water. By combustion of methane gas also you can get water. Any hydrocarbon on burning, one of the product will be carbon dioxide, another will be water. Here water is prepared by different methods, but the ratio in which inside the water hydrogen and oxygen are combined always in the mass ratio, that is 2 grams, because the atomic weight of hydrogen is 1, oxygen is 16. You can get it in the periodic table now. 2 ones are 2 eights are. It is 1:8 by mass only. Means in a compound, atoms of different elements combine in a definite proportion by mass, irrespective of the method of preparation, should be the statement of the law. This law was proposed by Proust. Note down the name of the scientist, Proust. Proust stated it for the first time. It is called as law of a definite. Joseph Proust prepared it for the, gave this particular law. This is very important law, right? The law, I think you have taken the example. Now we'll try to, after understanding is very important. Conceptual understanding is very important. Definite proportion. Let us write the statement now. Statement of the law of definite proportion. Statement of law of definite proportion. In a compound, let us write the definition meaningfully. In a compound, open the notebook, you may be asked for 1 mark. In a compound, atoms of different elements, atoms of different elements in a compound, atoms of different elements combine, atoms of different elements combine in a, better you call it as pure compound. In a pure compound, atoms of different elements combine in a definite proportion by mass. In a definite proportion by mass, comma, irrespective of ಅಂದ್ರೆ ಯಾವುದೇ ರೀತಿಯಿಂದ ಇರಬಹುದು, irrespective of method of preparation, irrespective of method of preparation means we have taken the example of water, irrespective of method of preparation. In a pure compound, suppose that you are asked for 1 mark, state law of definite proportion. Your answer should be, in a pure compound, atoms of different elements combine in a definite proportion by mass, irrespective of method of preparation, right? Grammatically meaningfully, right? Means just now we studied water can be prepared by neutralization reaction, water can be prepared by combustion reaction or any other methods, irrespective of the methods. What is the meaning of irrespective ಅಂದ್ರೆ ಏನು? ಯಾವುದೇ ಮೆಥಡ್ಲೆ ತಯಾರು ಮಾಡ್ರಿ ನೀವು, ಸಂಬಂಧ ಇಲ್ಲ ಅದಕ್ಕೆ. ಒಂದು ಮೊಲಿಕ್ಯೂಲ್ ನೀವು ತಗೊಂಡ್ರಿ ಅಂದ್ರ, ಸೇ ನಾನು ಇಲ್ಲಿ ವಾಟರ್ ತಗೊಂಡೆ ಅಂದ್ರ ಇದ್ರಾಗ ಹೈಡ್ರೋಜನದ ಮಾಸ್ ಎಷ್ಟದ ರೀ? 2 × 1 ಇಷ್ಟು ಆಕ್ಸಿಜನ್ ಎಷ್ಟದ? 16 ಅದ. 2 1s 2 8s 1:8. ಈಗ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೋಣ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್. ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಕ್ಯಾನ್ ಬಿ ಪ್ರಿಪೇರ್ಡ್ ಬೈ ಡಿಫರೆಂಟ್ ಮೆಥಡ್ಸ್. Now, I will show you what are the different methods of preparation of carbon dioxide. I think you have noted the definition. Keep a pen and paper working. By burning carbon and oxygen, you can get what? Carbon dioxide. You can burn any allotropic form of carbon, maybe coal, coke, charcoal. By burning it, you can get carbon dioxide. Or even just now we studied, by combustion of the methane also, you can get carbon dioxide plus water. You see, carbon dioxide can be prepared by different methods. Carbon dioxide plus liquid water, I think we balanced it 2:2, right? Carbon will be carbon balanced, oxygen will be 4, therefore 2O2, and it is balanced. Now, this is one method. Carbon can be obtained by directly burning charcoal, coke, coal in the air, you get carbon dioxide. When any hydrocarbon is burnt, you get carbon dioxide. LPG is burnt, you will get carbon dioxide. Any hydrocarbon, irrespective of the method of preparation of carbon dioxide, in the carbon dioxide, what is the mass of carbon? Atomic mass of carbon is 12 is to 2 into oxygen atomic weight is, there are 2 atoms of oxygen, atomic weight of oxygen is 60. You can get it in the periodic table. It is 12 is to 16 2s are 32. You can divide this common simplest ratio. 4 3s are 12, 4 8s are 32. You take carbon dioxide from any sample, any source. Carbon and oxygen in carbon dioxide will have a definite ratio by mass. What is the ratio? 3:8 by mass. That is the meaning of it. Hi, all of you. Yes. Welcome to the Lokji channel. Okay. That is a law of conservation of definite proportion. I hope you understood the meaning of law of definite proportion. Okay, fine. Now we will move on to the third law. What is the third law? Third law is called as law of multiple proportion. This was given by Dalton. You know, Dalton is a famous chemist who gave the first atomic theory called as the Dalton's atomic theory. Then after Dalton's atomic theory, further theories like Rutherford atomic theory came, Thomson's theory came, Rutherford, Bohr's model, Sommerfeld model, further development took place. So Dalton did pioneering work and he gives a multiple proportion. We'll try to understand what is multiple proportion with an example. Now, starting from carbon, suppose that you want to prepare carbon monoxide gas. For that you need oxygen. I will take a half O2 gas because you need carbon monoxide, right? I will take carbon. When burnt with oxygen, you can get what? Carbon dioxide gas. Now, atomic weight of carbon is 12 grams. You can check in the periodic table. For practical purposes, we'll take it as 12 grams. And 1 by 2 O2 means 1 oxygen atom. 1 oxygen atom means how many grams? 16 grams. Getting me? Here, in the second case, mass of carbon is 12 grams. Mass of oxygen is 32 grams. Right? Now observe what? Carefully observe that. Here 16 gram of oxygen in the formation of carbon monoxide, carbon dioxide are two different compounds. Carbon monoxide is poisonous. Carbon dioxide is not poisonous because we are exhaling it, plant are inhaling it. Non-poisonous. Different compounds. See, the reactants are same. Means carbon. Mass of carbon is fixed, that is 12 gram. But the mass of oxygen in the formation of carbon monoxide is 16 gram. In the formation of carbon dioxide is 32 gram. What the law of multiple proportion given by Dalton states that when two or more elements combine to form, when two elements combine to form two or more products. Observe, two elements are carbon and oxygen. When two elements combine to form two or more products, they are combining to form what? Two products here. One product is carbon dioxide, another product is carbon monoxide, another product is carbon dioxide. When two elements are combined to form two or more products, right? Mass of one of the elements which combines with fixed mass of the another element. Whose mass is fixed here? Carbon mass is fixed, 12 gram. So mass of one of the element is oxygen, which combines with the fixed mass of the another element. Right? So these two bear a simple whole number ratio. That is, if I take in the formation of carbon monoxide, mass of oxygen is 16 gram is to mass of oxygen in the formation of carbon dioxide is 32 grams, it will be a 1:2. It will be a simple whole number ratio. Try to understand the meaning of it. Here, what is the statement of the law of multiple proportion? When two elements combine to form two or more than two compounds, right? Mass of one of the elements, here oxygen, which combines with the fixed mass of another element, whose mass is fixed? Carbon. Then, right, the masses of the first element, that is oxygen, bear a simple whole number ratio. I hope you understood what is the meaning of this law. Okay, is the board visible to you? Can you see the board clearly? Okay, you can interact, clarify the doubts. Okay, let us write the statement. Let me repeat. What is the law of multiple proportion? First of all, you take example. All of you noted the example. You note down the example. Now we will state and try to remember it. You will be asked to check. Right? Let us write the statement of law of multiple proportion. Statement is when two elements two elements combine to form two or more combine to form two or more products the masses of one of the elements which combine with first of all you understand the law, then we will see the questions. The masses of one of the elements which combine with fixed mass of another element fixed mass of another element bear a simple whole number ratio bear a simple whole number ratio bear a simple whole number ratio already you have taken example. I hope you understood the meaning of it. If you understand it, writing becomes very easy. When two elements, better you write two elements, make the corrections, don't do mistakes in writing the definitions, have writing habits. When two elements combine to form two or more products, important, the masses of one of the elements, in the example oxygen, which combine with fixed mass of another element, bear a simple whole number ratio. Are you getting this idea? We'll understand it better by taking another example, right? I will take another example. Okay, now see here. You know nitrogen? Yes, sir. Nitrogen is a gas, right? Nitrogen can combine with oxygen forming different oxides. Number of oxides nitrogen can form. It will form one of the oxides called as N2O. It is called as a nitrous oxide. Remember, nitrous oxide. It is a laughing gas. It is known as laughing gas. Remember, chemistry students. Nitrous oxide was prepared by Humphrey Davy, and once you inhale this particular nitrous oxide gas, your muscles will loosen. Person feel like laughing. Therefore, it is called as laughing gas. And nitrogen can combine with the same oxygen gas, forming nitric oxide. Look at here, nitric oxide. Number of oxides it will form will take only 3. So same nitrogen can combine with oxygen, forming what? Nitrogen dioxide. This is reddish brown in color. Look at here, reddish brown in color. All of them are gases, and its nitric oxide color cannot be recognized because as soon as it is liberated, it combines with oxygen of the air, forming nitrogen dioxide. Therefore, color of nitric oxide cannot be recognized. Okay. Now, our question is, these element reactants are same. Nitrogen is combining with oxygen. Here also nitrogen is combining with oxygen. In the first case, it forms a nitrous oxide. For that, I will take 1/2 O2. I will fix the mass of nitrogen. Mass of nitrogen is, what is the atomic mass of nitrogen? 14. 14 2s are 28 grams. Okay. Now, nitric oxide, right? So, let me take 2NO here. Now, the equation is balanced. Now, 28 gram of nitrogen combines with what? 16 2s are here. Nitrogen, 28 gram of nitrogen combines with how many atoms of oxygen? Observe, number of oxygen atoms is 1. 1 means how many grams? 16 grams. Here, in the formation of nitric oxide, the mass of the oxygen is 16 to the 32 grams. Right? Now we want nitrogen plus oxygen forms 2NO2. Already 2 nitrogen atoms are balanced. To balance oxygen, I must take 2 O2. There are 4 oxygen atoms. 16 4s are 64 grams. Observe. The mass of the nitrogen is not disturbed. Right? Same nitrogen and oxygen are combining, forming how many products? 3 products. One is nitrous oxide, nitric oxide, nitrogen dioxide. Have this example. Illustrate law of multiple proportion with an example. Will be a good question for 2 marks. You can give the first example or you can give this example. What is the statement of the law of multiple proportion? It states that when 2 or more elements, when 2 elements combine to form 2 or more products, right? The masses of one of the elements that combine with the fixed mass of another element. Whose mass is fixed here? Nitrogen mass is fixed here. You can observe. Mass of nitrogen is fixed here. But the masses of oxygen are different. The masses of other element which combine with the fixed mass 28 gram, 28 gram, 28 gram of nitrogen, they bear a simple whole number ratio. If I take 16 in a nitrous oxide is to 32 in a nitric oxide is to 64 in a nitrogen dioxide. Cancel them. 16 ones are 16 twos are 16 4s are 64. They 1 is to 2 is to 4. Means they bear a simple whole number ratio. Is called as law of multiple proportion. That is, you understood, I hope, clearly, law of multiple proportion. Is that clear? Is that clear? Okay. If you have got any doubts, you can clarify. Okay. Now, we will continue with the Gay-Lussac's law of combining volumes. You can consider, right? No doubts in it? Okay. Now, let us continue with the next law. Okay. Let us consider the next law. See. That is Gay-Lussac's law of combining volumes. Sometimes we call this Gay-Lussac's law of combining volumes. Combining volumes is the statement of law of definite proportion of gases. That is Gay-Lussac's law of combining volumes. Gay-Lussac's law of combining volumes. Combining volumes is a statement of law of definite proportion of gases. Law of definite proportion of gases. Is the point clear to you? Law of definite proportion of gases. Why it is called as law of definite proportion of gases? Yes. Means, suppose that I take one example. I will take a nitrogen gas, allow it to react with a hydrogen gas, S2 gas, to form ammonia gas. This is prepared in the laboratory under suitable conditions. Let us not worry about it. Now, I have written skeletal equation. When nitrogen combines with the hydrogen in a definite proportion under suitable conditions, you will get ammonia gas. Ammonia gas is a pungent smelling gas. Nitrogen and hydrogen are colorless gases, odorless gases, but ammonia is pungent smelling gases. Check whether the equation is balanced. So balance it now. How many nitrogen atoms on the left? There are 2 nitrogen atoms, therefore I must take what? 2 nitrogen, law of definite proportion. That is a law of conservation of mass. Nitrogen atoms are balanced. Now what happened to hydrogen? There are 2 hydrogen atoms on the reactant side. How many hydrogen atoms on the product side? 6 hydrogen atoms. Means how many hydrogen atoms are created now? 4. Therefore, it is against the law of conservation of mass. Therefore, I must take 3s2. Now check 3 2s are 6 hydrogen, 2 3s are 6 hydrogen, and it is balanced. If I take the volume, generally gases will have volume. Will not consider. That is 1 volume of hydrogen combines with 3 volume of 1 volume of nitrogen combined with 3 volume of hydrogen to form 2 volume of ammonia. Right? When a gas is combined, or gas is produced by the chemical reaction, right, the volumes of the gases of all reactants and products will bear a simple whole number ratio. That is, nitrogen is 1, hydrogen is 3, and ammonia is 2. 1 is to 3 is to 2. Are you getting me? And if you take carbon monoxide gas plus oxygen gas forms carbon dioxide gas. Balance the equation. All of them are gases. Carbon monoxide is a gas, oxygen is a gas. When combined, you are getting carbon dioxide gas. Balance the equation. What do you get here? Carbon 1 atom, 1 atom. Oxygen atoms are how many? 3. Odd number. Whenever you get odd number of atoms, make it as even by taking 2 CO. Now observe. 2 oxygen, 2 oxygen. Now what happened now? Carbon atoms are 2 now. Therefore, I must take the product as carbon atom 2. Carbon atoms are balanced, means neither created nor destroyed. What happened to the oxygen atoms? 2 oxygen atoms in the carbon monoxide, 2. 2 plus 2 is 4. 2 2s are 4. Means it is balanced. In terms of volume, if you take 2 volume of carbon monoxide reacts with 1 volume of oxygen, forming what? 2 volume of carbon dioxide. Means all the reacting gases and the product gases bear a simple whole number ratio, is called as law of definite proportion. I hope you are getting me. Okay, but all the gases must be measured in water under similar conditions of same temperature and pressure. All the gases are in the same conditions of temperature and pressure. Temperature and pressure should be same. I think you understood. Let us write the statement, right? When gases react or gases produced in a chemical reaction, the volumes of the gases the volumes of the gases bear a simple whole number ratio. Provided all gases are at similar conditions of temperature and pressure. Means temperature and pressure of all the combining gases must be same. Temperature and pressure. temperature and pressure. Study the law, statement of the law correctly. When gases react or gas is produced in a chemical reaction, the volume of gas is beer simple whole number ratio, provided all gases are at similar conditions of temperature and pressure, is called as Gay-Lussac's law of combining volumes. It is also called as law of definite proportion of gases. So there you take masses, but here you take volume. When gas is there, you are in a law of definite proportion, you are taking mass ratio. Here you are taking volume ratio. That is the main difference. Therefore, sometimes the Gay-Lussac's law of combining volumes is also called as a law of a definite proportion of gases. I hope you understood these laws, my dear students. Let us continue with the last thing. So Avogadro. Yes, Avogadro is famous for his number. Anybody knows what is Avogadro's number? Avogadro's law. What is the statement of the law? We will try to understand. What is Avogadro's hypothesis or Avogadro's law? So let us take two flasks, right? I will take two flasks, right? Here is one flask. Here is another flask, right? Right. I will take in one hydrogen gas. I will fill in one, and oxygen gas I will fill in another flask. Suppose volume of the flask is 400 cc. V1. V2 is also 400 cc. Volume of the second flask is 400 cc. This is first, this is second. Suppose the temperature of one is 373 Kelvin, and the temperature of second is also 373 Kelvin. Suppose the pressure, right? Suppose pressure is say here also 3 atmosphere. Here also pressure is 3 atmosphere. What is the statement of the Avogadro's law is that? Under similar conditions of temperature and pressure, different gases, right, contain same number of molecules. Suppose the hydrogen molecules are 10,000 here. The number of N1 is number of hydrogen molecules, N2 is number of molecules of oxygen. The concept of molecule, as on date we know, the concept of molecule as we are using now was for the first time given by Avogadro. Even Dalton was not accepting it. At that time when Avogadro gave this law, the concept of molecule, Dalton believed that it is a cluster of atoms. Molecule does not exist. Now you know that as on date we know that hydrogen does not exist as H, it exists as H2, called as diatomic. I told you in the bridge course. Oxygen does not exist in the nature as O, it exists as O2, diatomic molecule. Hydrogen, diatomic molecule, right? Even chlorine does not exist as chlorine, it exists as Cl2. Are you getting me? Ozone does not exist as O, it exists as a triatomic, right? Phosphorus does not exist as 4, it exists as P4. Sulfur exists as S8. So these are molecules, elementary molecules. This concept of molecules was given by Avogadro. He said that equal volumes of all gases. What is the volume of it? 400 cc. Gases will not have definite volume. They will have the volume of the container. Suppose the volume of the container is, both the container is 400 cc only. Equal volumes of all gases. Note 400 cc, 400 cc. Under similar conditions of temperature, 373 Kelvin, 373 Kelvin. Under similar conditions of temperature and pressure, 3 atmosphere, 3 atmosphere. ಅಂದ್ರೆ equal volumes of all gases under similar conditions of temperature and pressure, they contain equal number of molecules. Is the wonderful contribution of Avogadro, right? And based on the Avogadro, right, we are defining the mole concept. Now, one mole, I am coming to the point now, the mole concept was developed by Avogadro's law only. What is the statement of the law? I'll repeat it. Try to understand. First step is understanding. Next step is explain it again. Okay, no problem. You take two flasks. You take two flasks. Say, volume of the flask is 400 cc, 400 cc, available in the laboratory. You fill a hydrogen gas in one and close it. Oxygen gas is another one it and close it. And let the temperature be 373 Kelvin, means 100 degrees centigrade. Both of them are having same temperature, same volume. Let the pressure be 3 atmosphere, 3 atmosphere. Pressure is same, temperature is same, volume is same. Right? What is the statement of Avogadro? ಏನು ಹೇಳ್ತಾನಂದ್ರೆ, ರೈಟ್, ಎರಡು ಬೇರೆ ಬೇರೆ ಗ್ಯಾಸ್ಗಳು ಒಂದೇ ವಾಲ್ಯೂಮ್ ಇದ್ರ, ಒಂದೇ ಟೆಂಪರೇಚರ್ ಇದ್ರ, ಒಂದೇ ಪ್ರೆಷರ್ ಇದ್ರ, ಇದರದ ನಂಬರ್ ಆಫ್ ಮೊಲೆಕ್ಯೂಲ್ಸ್ ಏನಿರ್ತಾವಲ್ಲ ಒಂದೇ ಇರ್ತಾವು. ಇದು 100 ಮೊಲೆಕ್ಯೂಲ್ಸ್ ಇದ್ರೊಳಗಿದ್ರೆ ಇದ್ರೊಳಗೂ 100 ಮೊಲೆಕ್ಯೂಲ್ಸ್ ಇರಬೇಕು ಅನ್ನೋದನ್ನ ಹೇಳಿದ. ಐ ಹೋಪ್ ಯು ಗಾಟ್ ಇಟ್ ನೌ. ಅದನ್ನ ನಾವು ಇಂಗ್ಲಿಷ್ ಒಳಗೆ ಹೇಳ್ತೀವಿ ಈಕ್ವಲ್ ವಾಲ್ಯೂಮ್ಸ್. ಅಂದ್ರೆ ಒಂದೇ ವಾಲ್ಯೂಮ್ ಇರುವಂತವು, ಒಂದೇ ಟೆಂಪರೇಚರ್ ಆಗಿರುವಂತವು, ಒಂದೇ ಪ್ರೆಷರ್ ಇರುವಂತಹ ಬೇರೆ ಬೇರೆ ಗ್ಯಾಸ್ಗಳನ್ನ, ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ತಗೊಳ್ರಿ, ಆಕ್ಸಿಜನ್ ತಗೊಳ್ರಿ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ತಗೊಳ್ರಿ, ಇಲ್ಲಿ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ತಗೊಳ್ರಿ, ಬೇರೆ ಬೇರೆ ಗ್ಯಾಸ್. Right? So, equal volumes of, right? Equal volumes of, right? Equal volumes of two or more gases under similar conditions of temperature and pressure contain equal number of molecules. Contain equal number of molecules is called as equal volumes of all gases, whatever may be the gas, contain equal number of molecules, right? Equal number of molecules. Let us write the statement. I hope you understood now. Arpita, is that clear? Okay. Equal volumes of, let us write the definition of it. Equal volumes of all gases, equal volumes of all gases under equal volumes of all gases under similar conditions of temperature and pressure, under similar conditions of temperature and pressure, under similar conditions of temperature and pressure, contain, temperature and pressure contain, right, equal number of molecules, equal number of molecules. This was a turning point. Even though in the honor of Avogadro, we are rating the Avogadro number Na as 1.622 into 10 raised to 23 is called as Avogadro number. 6.022 10 raised to 23. I will talk about it in the next class. So that is Avogadro's number. I hope you understood in this class all the laws. So in the next period, before coming to the next period, you study by Monday atomic weight, molecular weight, mole concept, you study them and attend the class, and empirical formula and molecular formula we will cover in the next week, and almost I will try to complete the chapter in the next week. Okay, that's all for today. Tomorrow Saturday I am moving on to Gadag. There is a workshop. Arpita, you can inform your friends. You can also come between 10 to 1 there to clarify your doubts. Saturday I am planning to take class there. If arrangement is done, I will let you know. Tomorrow Saturday evening class. I will let you know, because I have to carry this setup there, and there I have to make arrangement. If the arrangement tomorrow by morning I will be there in Gadag, right? 2 days I will be in Gadag, 5 days I will be in Dharwad, and from Gadag I am planning to give you the live stream, and I will let you know by afternoon. If the setup is done, I will let you know. Otherwise, I will put it in the WhatsApp group. Directly we will meet on Sunday or Monday or Sunday evening. I will just check it out. Saturday, Sunday, I will set. If everything is set there, I will take the class from there only, and I will let you know in the WhatsApp group. Okay, that's all, my dear students. And if you like Lokji channel and these classes, please invite one student, join to the Lokji family, and any relatives present around Karnataka, you can inform them. And there is a workshop on speed maths on Sunday at Gadag. Similarly, I will take workshop at Dharwad also. And this week, first workshop I will start in Gadag branch. Already I have put it in my WhatsApp status. Between 9 o'clock to 1 o'clock, I will be available in Dharwad, in Gadag this Sunday. Between 9 to 1, I will go on taking 8, 9, 10 students, combined Vedim's workshop, right? If possible on the projector, and even the live class I may take from Gadag also, I will let you know. Some arrangements are going on. Okay, that's all, my dear students, today. So, in the next class, we will continue with study atomic weight, molecular weight, mole concept. It is a numerical based chapter. It's called as stoichiometry. What it is called as stoichiometry. About that, I will talk. These were the laws, and this part will be mathematical part. I will teach you. It is very much required for 11th and 12th standard every now and then. They are the basic things in chemistry. If you make it perfect, your physical chemistry you are learning in 11th and 12th, or whatever numericals you are solving, without these basic understanding, you cannot solve competitive exam numericals, even theory numericals. If your knowledge in basic concepts in chemistry is weak, right? That's all, my dear students. Bye bye. See you in the next class. I will let you know tomorrow at what time your class will be there on Saturdays and Sundays. What are the extra things? And the tests will begin now. Assignments will begin now. Okay. And just I'm setting up the Gadag. Gadag students can visit at Gadag. Right? Okay. That's all for today, my dear students. We'll continue in the next class.